Hi, let us discuss what is embedded C. Normal C program is designed for target of x86 architecture, which is nothing but our personal computer. The C compiler has the knowledge to compile the code for the target of x86 because it knows the internal architecture in terms of its registers and memory and cache architecture, etc. When you go for embedded systems are designed with a variety of microcontroller architectures or microprocessor architectures. Each microprocessor or microcontroller differ in terms of its internal resources like number of registers, name of the registers, and number of peripherals and internal memory. So a normal C compiler doesn't have the knowledge about a particular target of microcontroller. If we want to utilize the C program for embedded system design, that means for target microcontroller, we should educate or inculcate the knowledge about the microcontroller into the C compiler. Then only the C compiler will able to handle the code to generate executable code for the target microcontroller. Because the internal resources available in the microcontroller to be known to the compiler in order to generate successful execution code. These knowledge of internal resources and availability resources can be incorporated into normal C. Then the normal C program is called as embedded C. There are two ways we can inculcate or feed the knowledge about the target microcontroller into compiler. The first method is in terms of header files. We can define a number of header files about the devices, their internal architecture, their internal resources like number of ports, registers and peripheral, etc. Those registers and all other resources are defined in the header file as a variable. This variable kind of definition in the header file will make the C programmer to utilize that resources in their program as how they are using a normal variable. An example statement of include of the header file is given here. You can see include HC705C8 header file, which includes the header file of XC705C8 microcontroller, which has the definition of all these registers and peripherals in the microcontroller. And another example is avr.h, which has the definition or internal registers or memory content information in the header file of avr.h for avr family of microcontroller. And second method of feeding the knowledge to the C compiler we can make through assembly, or we can call it as compiler directives. The programma is the famous directive which can use for specify or define the resources of target hardware microcontrollers such as available memory, port and some specialized instruction. So using this hash programma directives, we can feed additional information to the compiler in order to enable the compiler to successfully generate executable code for the target microcontroller. The sample usage of the programma statement is given here. You can see that these two statements define port A and port B as a variable called port A and port B. You can see the port A variable is nothing but the physical address of hexadecimal 0, which is nothing but port A inside the microcontroller. And port B variable is nothing but the physical address of hexadecimal 1, which is nothing but port B inside the microcontroller. And reading this statement, the compiler will come to know the port A and port B variables are nothing but the physical addresses of hexadecimal 0 and hexadecimal 1, and which is the type of port and which is read and writable.